Hey guys, so welcome to another whiz. I hope that you guys start whisking this in your notebook. Today we're going to focus on solving multi-step equations and manipulating formulas with the do-undo results table. Now I know that a lot of you have already seen this. I just want to quickly review it, but more importantly we're going to apply the do-undo results table to manipulating formulas. Oftentimes you'll be asked, it's really called literal equation manipulation. You're solving someone's formula they come up with or someone's expression or equation for just a specific variable, not even solving for an answer. So on the screen you'll see kind of a hodgepodge of materials that is used to wrap presents. I just want to refresh your memory on what we did last year in 8th grade as wrapping presents, or in 8th grade math pre-algebra. What you do is you put the present in the box, lay it on top of the paper after it's cut. I'm going to fold the paper. I'm going to tape that paper. And then what I'm going to do is I'm going to tie the ribbon around it. And I'm going to give it to my friend or whomever I want. And the first thing they're going to do is to undo the last thing I did. In this case, it was the last thing I did was to tie the bow. So the first thing they're going to do is untie the bow. And then every step after that is just undoing what I did in reverse order. Now that is actually the properties of equality. You know, your subtraction properties of equality, your addition properties of equality, your multiplication and division properties of equalities. The most important thing is when we start doing this and we move away from the table, you continue to do it to both sides of the equal sign. Okay, so let's jump right in. Here on your screen, you'll see an expression. Let's build it first. Just like we did in class, we're going to build it. Pretend this is just a good old number trick. So when I'm building this, first thing I'm going to do is just lay it out like we did with the table. When in doubt, table it out. And let's call this my do column, and let's call this my undo. Okay, I'm not going to have a results column yet because it's just an expression. I'm not going to be solving for anything. I just want to refresh you guys on how to build it. So here's my variable. Whatever you're looking for always goes in this first row, so to speak. And then if you look here, I like to put a box around my variable and whatever is attached to it. In this case, the first thing here's my number, here's my variable. The first thing what happens to my variable is it gets divided by 4. After it gets divided by 4, inside the parentheses, it's being increased by 7. After it's being increased by 7, it gets multiplied by 2. I know that because we're going left to right. Order's operation tells me that I do multiplying before subtraction, and then lastly, I do negative 8, or 8 gets taken away from the left side. So if I'm going to undo this, unwrap it, so to speak, the first thing I need to do is I'm going to add 8. Divide by 2, subtract 7, multiply by 4, and if later on, let's say this is equal to 9, what you would do is you would do the properties of equalities by doing the inverse operations. So this undo, going from here all the way up, that is my inverse operation. If I see this, and the first thing I'm going to do is add 8 to both sides, that's my addition property of equality. Next, I would divide both sides by 2, and that's the property of equality. Now, most of you are wanting to distribute this 2 if you want. You can if you want. You don't have to because we are just trying to find x later on or whatever. You're just undoing the operations. Okay, so that's just how you would build it and then unwrap it or undo it, so to speak. All right? So take a moment, write this down, and let's actually apply this. So first thing we're going to do is, this is called the expression. We also call that the do column, just the shorthanded. So here's my number. I'm going to say it out loud first. I have a number. It gets increased by 3, gets multiplied by 7, subtract 4, and then divided by 2, and then take away 1, and my result is 123, or 123. So before I even start solving it, I'm just going to build it first. Okay? Here's my variable, so to speak. Here's pick a number, like in number tricks. First thing that happens to it is it gets increased by 3. After it gets increased by 3, it gets multiplied by 7. After it gets multiplied by 7, it sits with negative 4, or 4 is taken away from it, or subtract 4. And then it gets divided by 2, and then minus 1. I know that minus 1 is the last because it's not part of my expression. If you want to, you can kind of see that really that's what's happening over here before we take away the 1. My result, 123, it always goes here. whatever the number or the constant that's by itself is always going to go at the very bottom of your results column. And then before I even do any of the math, I'm just going to go in and do the inverse operation of each of the step that I built. So I know that I need to add 1 because those are inverse of each other. I'm going to multiply by 2 because multiplying by 2 undoes dividing by 2. The opposite of -4 is +4. Now this is important. The actual value of the number never changes, only the operation. -4 doesn't become plus -4. Okay, really that's just -4. The opposite of -4 is +4. If you have a positive over there, the opposite of that would be negative. You don't change the value of the number, so to speak. You're just changing the operation. You're doing the inverse operation. This would be multiplying by 7, so I'm not dividing by -7. I'm just dividing by +7. Again, the integer stays the same. The opposite of +3, -3. And that's basically it. And then from here, we just take with our calculator ready. Now, careful not to, just like in number tricks, at the end of every arrow, you hit enter, you write it in so that your calculator doesn't just try to run all of it at once, which could be problematic because it will really do the orders operation as you type it in without understanding that you meant to have a break here or there. So 123 plus 1, put the result right here, it's 124. Okay, 124 times 2 will be 248. 248 plus 4 going back in is going to be 252. 252 divided by 7 is going to be 36. 36 take away 3 is going to be 33. And there's nothing left, so there's my answer. X is equal to 33. I like this way of doing it at first because it tells you this is what's happening. This is the do column, and then this is the reverse order of it, going back up. I can quickly check my work, but once I get my result here, 33, and run it back through this column and say 33, okay, you can just have a calculator ready, 33 plus 3, hit enter, 36, times 7, enter, is equal to 252. Take away 4, 248, divided by 2 is 124. Took away 1, and I get 123. So it goes full cycle, and you see the inverse operations. Now, you don't have to solve equations this way, but technically speaking, whenever you're solving equations, and you guys know that, if something's being added by 3, I need to subtract 3 to undo that. You do it to both sides. This is what's really happening. You guys have been doing this all along. We're just laying it out so that you can see the relationship. Okay? Let's move on. And then I'm gonna, oops, didn't mean to show you that. Then I'm gonna jump in and let's do what's called literal manipulation. Given that C is equal to 2 pi r, solve for r. In this case, it's relatively simple. You get circumference is equal to 2 times pi times r. I'm not actually solving for anything, so to speak. I'm not solving for an actual number. I'm just manipulating this formula for the given variable. So I'm gonna build it first. And most of you can probably do this without actually having to do this, but we're just going to go step by step. And I'm going to show you how to apply this table to a formula when you are asked to solve for a variable rather than just a number. Okay, so I'm looking for the radius. So it goes right there. The radius goes right there because that's what it's telling you right there. And I'm just going left to right. Okay. First thing is, here's the radius. It gets multiplied by 2, gets multiplied by pi, because here's what's given to me, and then I'm just going to run it back through. And in the last slide, I talked about how whatever's by itself, the constant goes right here. So here's my circumference. It's just going to go right there. It's kind of weird because I'm not actually going to put any number in. And then I'm going to go in and undo it. Divide by the pi, divide by 2, and then I should have my radius right there. So then if I go in, so the first thing I do with C to solve for r, that is given that C is equal to 2 pi r, is divide both sides by pi. Again, I'm going to take this and run it back in. Divide by 2. So let's say that I get an answer and then I divide by 2. Well, technically speaking, circumference, because I'm not going to divide by, I'm not going to say c divided by pi divided by 2. If this is the case, you know that that's the same thing. Dividing by 2 is the same thing as multiplying by 1/2. What happens here is I get c is equal to c over 2 pi, because I'm multiplying fractions. Okay, so whenever you're dividing by a number, it's the same thing as multiplying by its reciprocal. In this case, dividing by 2, the reciprocal of that would be multiplying by 1/2. But you don't really have to do that, all that. You can just take the entire expressions and divide by, divide by, I don't know why it's doing that. Hold on, let me fix that. Divide by 2 pi. Okay, so I mean technically if you wanted to, you could have just done, here's my do, here's my undo, here's my results. Okay, here's my columns, here's the radius. First thing I notice that it's all multiplying. It's all multiplying by 2 pi r, so 2 pi. So here's my circumference. The fastest way, as you get used to this, knowing that it's all associative property multiplication here, the inverse of that, you just divide both sides by 2 pi. And that is only circumference is equal to 2 pi. So radius is equal to circumference over 2 pi. I'm not actually solving for a number. I'm not actually finding the radius. I'm rearranging my formula so that later on if somebody gives me the circumference, I want to find the radius, I just take the circumference divided by 2 times pi, or the approximation of pi. Okay, so either of this would work. This might be a little bit more complicated at first. If you go, oh, I'm dividing by pi, then divide by 2, that looks really weird. Just remember that if you're dividing, it's the same thing as multiplying by its reciprocal. So then here's the last problem for today. I just wanted to, again, continuing in some just solving, given an equation, we're actually manipulating it, rearranging things so that we can find for the given variable. And actually not solving for anything. This one is just, I just made this one up. I have v times the quantity of a plus b divided by c minus d is equal to g. And I need to solve for a. So the first thing I'm going to do is I'm just going to build it again. And this time again, we're going to build it, and then every step of the way we're going to carry what we previously manipulated onto the next one until we have nothing but left. That's but a. So here's my do, here's my undo, and here's my results. Okay, so I'm looking for a, so I'm just going to put it right there. Now later on, if you have, let's say you have an equation that has something squared, the undoing that would be square rooting. But more importantly, if you're going to square root, get a square root both sides. We'll look more examples of those in class, especially like Pythagorean theorem or something. So here's a. The first thing that happens to it, closest to it, it gets add by b. I can see that right here. I'm going to go ahead and put parentheses inside inside the big parentheses, so that I know that this belongs to each other because it's being connected. It's separated by this division right here. So after it gets added by b, it gets divided by whatever c minus d is. Because of it's being divided by whatever c minus d is, I'm going to divide by whatever c minus d. I'm going to put that as one term, as one quantity, because it actually is, I'm dividing by whatever c minus d is. I'm not going to separate the two because they belong together. And after that, it gets multiplied by v. Again, this whole doing part, that's just like our number tricks. My result is I get g. So the first thing I need to do to both sides is divide by v. And then after that, I get multiplied by whatever c minus d is, or just c minus d, and then subtract b. Okay, so the first thing I'm going to do is take g divided by v. So it looks something like g divided by v. After that, I'm going to multiply by the quantity of c minus d, and this is what it looks like mathematically. I'm going to do it over here. G divided by v multiply by c minus d over 1, because it's one quantity. So quickly I can just go, oh, g divided by v multiplied by c minus d over divided by 1, that's the same thing as saying GV times C minus D. Okay, or you can also rewrite it as G times C minus D over V. Okay, all three of these is what the same thing as what's happening here. So I'll go ahead and choose this last one right here. Just multiplying my fractions. So just write it in. G times C minus D divided by V. And then the last thing I need to do is subtract B from both sides. So then what I end up having is G times C minus D divided by V minus B. And that's what A equals. So I'm going to write it over here. A is equal to G times C minus D divided by V minus B. Now if you take a moment and look at my final expression or equation that I saw for A, G is sitting by itself and everything else is happening to G because I'm undoing the entire process to get A by itself. You see that it's being divided by C minus D, so there's the time C minus D. I saw that it was being multiplied by V, and there's that dividing by V. Because the last thing that happened, technically speaking, the last thing that happened over here was being multiplied by V. So the first thing that happens to G is gets divided by V. Because I am dealing with properties of multiplying fractions, it's dividing by C minus D basically gets multiplied by C minus D, puts it into the numerator. So that's all I really have today. I just went over some quickly on how you would manipulate equations and formulas for a given letter by doing and undoing and practicing properties of qualities. Do pause it, rewind it, watch it again, and then we will add a couple more problems when we get to class. Thanks, guys.